Good morning, students. Yeah, this is the ninth part of basic inequalities. Important part. Today I am going to explain logarithmic inequalities. First of all, I want to explain what is the definition of logarithm of a real number. Okay, observe here. If any equation of the form a power x equal to n, then x is called logarithm of n to the base a with some conditions. Okay, so symbolically x is equal to logarithm of, no need to write total, just you write logarithm of n to the base a. Okay, listen students, any equation of the form a power x equal to n under conditions, that is important. X is called logarithm of n to the base a. See, double implies a power x equal to n, then this happens. If this happens, then you can write like this. Okay, so what are the conditions, that is important. Initially, mathematicians are given definition for logarithm. Any equation of the form a power x is equal to n, then x is called logarithm of n to the base a. By using the definition, we get some wrong conclusions in mathematics. See here, 1 power 3 equal to 1. According to this definition, 3 is called logarithm of 1 base 1. Logarithm of 1 base 1. So 1 power 4 also 1 only. So according to their definition, 4 equal to logarithm of 1 base 1. Okay, so here I need to write 3 equal to, okay. Observe here, RHS parts are equal for these two equations. Logarithm of 1 to the base 1, logarithm of 1 to the base 1, this is equal to 3, this is equal to 4, obviously 3 equal to 4, which is mathematically wrong. Which is mathematically wrong. That's why they don't want to take base as a 1. Here, A should not take as a 1, that is first condition. So, A is not equal to 1. Okay, next. For example, 2 power 3 equal to 8. This can be written as 3 equal to logarithm of 8 base 2. Okay. 2 power 4 equal to 16. This can be written as 4 equal to logarithm of 16 base 2. According to definition. Minus 2 power 4 also 16 only. So this can be written as 4 equal to logarithm of 16 base minus 2. So LHS parts are equal. RHS parts should be equal, but looking just like odd, because log 16 base 2, log 16 base minus 2. Okay, that's why the bases are not taken as negative real numbers. Second condition. First condition, A not equal to 1. Okay, first condition, A not equal to 1. Second condition, A not equal to negative real number. So A should be greater than 0. These two are the first conditions for this equation to write it into logarithmic form. Okay. Next important things here. What happened here? A is a positive real number and A not equal to 1. Okay. So take any exponent. For example, A is taken as 7. 7 power x. Any x. X is positive or negative. This is positive only. 7 power 1, 7. 7 power half, root 7 positive. 7 power minus half, 1 by root 7 positive. Means any real x, 7 power x is positive. Understood? Means if A is a positive real number, for any real exponent, the resulting is also positive. Resulting means n positive. Okay. Final conclusion. Final conclusion. Initially, what is given the definition? Any equation of the form a power x equal to n, then x is called logarithm of n to the base a. But after getting these type of results, so mathematicians are rearranged or redefined the definition that any equation of the form a power x equal to n, where a greater than 0 and a not equal to 1 and n greater than 0, then x is called logarithm of n to the base a. So this can be symbolically written as x equal log n to the base a. Under these conditions only, in this equation, x is called logarithm of n to the base a. Okay. This is called exponential function. This is called logarithmic function. In exponential function to logarithmic, condition should apply. Okay. Logarithmic exponential function, same condition should apply. Means x equal log n base a, then n equal to a power x. To write logarithmic to exponential, we need to follow these three conditions. Or exponential to logarithmic, we need to follow these three conditions. Okay, this is the definition of logarithm of a function. But actual today's class is logarithmic inequalities. I don't want to explain what are the properties of logarithms, what are the laws involved in logarithms. I don't want. Just I want to explain logarithmic inequalities. A power x equal to n double implies x equal to log n base a with condition, star mark with condition. What is the condition? Your a should be greater than 0, n should be greater than 0 and a is not equal to 1. N is greater than 0, n is positive. So here n means positive. Log of n to the base a. N is positive means logarithms are defined only for positive real numbers. Logarithms are defined only for positive real numbers. That is important thing. Okay, students, just I explained the definition of logarithm of a function. Any equation of the form a power x equal to n under condition means that a greater than 0, n greater than 0, a not equal to 1, then this x is called logarithm of n to the base a. N is positive real number, a is positive real number, not equal to 1, x is any real number here, x is any real number. Okay, we want to write the definition, we can write like this, definition. A comma n are two positive reals. Okay, in bracket a not equal to 1. If there exists, this symbol for there exists a real, I am saying real x, so that a power x is equal to n, then x is called logarithm of n to the base a. This is symbolic as x is equal to logarithm of n to the base a. A is any positive number not equal to 1. So there are two types of logarithms generally, common logarithms and natural logarithms. Common logarithms with the base 10. A is any positive real number and not equal to 1. Okay, so generally there are two types of logarithms, common logarithms and natural logarithms. Log x base 10 means the logarithms with the base 10 are called common logarithms. Common logarithms. Logarithms with the base e are called natural logarithms. Okay, logarithms with the base 10 are called common logarithms. Logarithms with the base e are called natural logarithms. Okay, so in textbooks they will give like this, log some x is given. The meaning of this is logarithm of x with the base 10. So they won't mention base, means you assume that the base is 10 only. Otherwise they will write like ln x. Ln x means logarithm of x to the base e. Ln x means logarithm of x to the base e. So all the properties of logarithms are applicable for both the natural and common. Just I want to write properties. Before that I want to explain that what is the x here. X is any real number. X is any real number. Observe here. I want to write here log n base a equal to x. X is any real number. No, it may be 2.7. It may be minus 2.7. It may be 0.47. It may be 10. It may be 0. Any real number, no? Any real number. It may be root 2. Okay, any real number. X is any real number. Important note. This is any real number. See here, n is positive real number. X is any real number. A is positive real number. Not equal to 1. Okay. N logarithms are defined only for positive real numbers. Here n, what you are writing n is called domain of the function. What you are getting outside x is called range of the function. Understood? Domain of the function means you can say that only positive real numbers. Domain, dome of logarithm. Generally, domain of logarithmic function is means here log n base a equal to x, then n should be in between 0 to infinity only. Okay, logarithms are defined only for positive real numbers. So what the domain means, we want to say that 0 to infinity. So x is called range, output range. What is the range? It may be 2, it may be minus 2.7, it may be 0.4. By the definition, x is any real number. That's why range is any real number. Range is any real number. Domain is positive real numbers. Range is any real number. Understood? Observe here. Logarithm of some x base some 2 given. What values of x? This is defined. Means your x should be positive real number. Means your x should be belongs to 0 to infinity. Okay. So in other words, logarithm of x plus 1 to the base some 7 is given. What values of x? This is defined. Means log of x plus base 7 defined. Means this is field just log n base a. n should be between 0 to infinity. N should be positive real number. Means your x plus 1 should be positive real number. Means what is the meaning of that? Your x plus 1 should be greater than 0. Greater than 0, not equal to 0 also. Greater than 0. So x should be greater than minus 1. Means what is the meaning of that? X belongs to open minus 1 to infinity. For these values of x only, log x plus 1 base 7 will define, or you can say that this is the domain of this function. Log x plus 1 base 7 given, but the domain means you can say that minus 1 to infinity. Okay, finding domains for logarithmic function is very important. Okay, students, here observe that x may be any real number, 2.7, minus 2.7, 0.47, 10, 0, root 2, anything. X is any real number. Important. Logarithm of n to the base a equal to any real number. Means x dot x. This is integral part, this is decimal part. Okay. Now, I want to define what is mantissa and characteristic of a logarithm of n to the base a. What is the mantissa and characteristic of log n base a? Important, Nana. First of all, you want to define mantissa, not characteristic. Log n base a equal to xx point xxx. The positive decimal part is called mantissa. Positive decimal part. Is called mantissa. Important. Positive decimal part. Rest integral part is called characteristic. Remaining integral part is called characteristic. Remaining integral part. What is called characteristic? Why I am saying like this? See here. Logarithm of n to the base a is equal to 2.17 given. Sometimes you want to write what is the characteristic and what is the mantissa. So I can say that first of all I want to write mantissa. Mantissa equal to 0.17. Characteristic equal to 2. Why I wrote positive decimal part? Positive, that is important, Nana. I want to take another example. Logarithm of some n base a equal to 0.0178 given. Just mantissa is nothing but 0.178 and characteristic nothing but 0. Okay. So another example I want to write here. Logarithm of n to the base a equal to some 2. Just 2. Mantissa I can write 0.00. Characteristic is 2. Minus 3 given. 0, 0 can write. Mantissa is 0.00. Characteristic is minus 3. This is also okay, but I will write here, that is important, Nana. Logarithm of n to the base a equal to minus 2.18. Minus 2.18. What is the characteristic? What is the mantissa? Important. Here mantissa is 0.18 is wrong answer. This minus is for total decimal. Actually what is there, Nana, here? Minus 2 plus minus 0.18. Mantissa definition already explained. Positive decimal part. So this is not positive decimal part. That's why this is not called mantissa and this is not called characteristic. Or in other words, you can say that given logarithm is not in standard form. Standard form means what? Your mantissa should be in positive. decimal part, remaining thing integral part. So that's why here I can't say that 0.18 is mantissa, minus 2 is characteristic, because given logarithm is not in standard form. Okay, we want make into standard form. We want to make this decimal part into positive decimal part. How? Just add 1, subtract 1. Nothing happened to the value, no? Why you want add 1? We can add 2, subtract 2 also. If you add 2 minus something, 1 point something, you will get decimal part. Already you know the definition. Decimal part should be positive. Decimal part, no, that should be greater than 0, less than 1. Understood? Greater than 0, less than 1. Mantissa means that one, Nana. Mantissa means greater than 0 and less than 1. Sometimes equal to 0 also, no, we are writing. Okay, sir, right. Greater than 0, greater than equal to 0, less than 1. That's why if you add 2, what happened, Nana? 2 minus 0.18 means 1 point something. 1 point something. Mantissa can't take 1 point something. That's why you need to add 1 and subtract 1. So what happened? Minus 1, minus 1, minus 2, plus 1 minus 0.18 means what? 0.82, I think. Correct only? 0, okay, 0.82. Now you can call 0.82 is the mantissa for log n base a, and minus 2, minus 1, minus 3. No? Okay, sorry. So now I can say 0.82 is the mantissa and minus 3 is the characteristic. Okay, interesting one. Log of n to the base a is given as minus 2.18. Here you can't say that minus 0.18 as a mantissa. So because negative is for total, that's why minus 2 plus minus 0.18. I added 1, subtracted 1. So I made a decimal part into positive, or I made a decimal part from 0 to 1. Okay, so what happened, Nana? Same number is nothing but minus 3 plus 0.82. These two are same only, value same only. Now here you can call the mantissa equal to 0.82 and characteristic is minus 3. Okay, how to write now? Logarithm of n to the base a, you got minus 3.82. Again wrong, representation wrong. Again if you write minus here, this is stand for total. This is minus 3.82 not equal to minus 2.18. That's why here you need to write minus. Here. Top of the 3 should write minus. What is the meaning of this? Minus 3 plus 0.82. Log n base a equal to, you can read as 3 bar 0.82. 3 bar 0.82 means minus 3 plus 0.8. So now I can say that in standard form. Now I can say that 0.82 is the mantissa and minus 3 is the characteristic. In this way you can find the characteristic and mantissa. Important, Nana. Logarithm of 723 base 10 equal to some value. So I don't want mantissas here. Just I want characteristic. What is the characteristic? What is the characteristic? Let the value be x. Don't remember or don't by heart formulae. By using definitions only you want to give the answers. Okay, Nana. 10 power x equal to 723. We want I am asking characteristic, no? Integral part I am asking. I don't want decimal part. Integral part. Okay, what happened here? See here. X value 723 means greater than 100, less than 1000. 3. X value between 2 to 3 means I can say this value is 2 point something. 2 point something. Something positive. Now I can call 2 is the characteristic. Okay. Don't count a number of digits 3 minus 1. That is not correct way to say the characteristic of the function. Because, for example, a problem is given. Logarithm of 723 base 6 given. Now we can say the characteristic. We can't say that digits 1, 2, 3 minus 1, 2 is the characteristic, becomes wrong. That formula is applicable only your base is 10. But I want characteristic of this logarithmic. Log 723 base 6 is given. We want to find characteristic. Just let it be x. We want to find integral part of x. Definition saying that this is nothing but 6 power x equal to 723. So 2 means 36. 3 means what? 36 6 are. Okay. Students, if you take x as a 2, 36. 3, you get 216. This value is greater than 216. If you take x as a 4, you will get 1296. The value lesser than means what is the meaning of this? Your x should be lies between 3 to 4. Your x should be lies between 3 to 4. That's why I can say that this value is 3 point something. 3 point something. Now I can say that 3 is the characteristic for this problem. log 723 base 6 is given. What are the characteristic means? I can say 3.